Welcome to this session on CCNA tutorial Network Fundamentals. This video is aligned with Cisco's official CCNA 200-301 exam blueprint and is designed to guide you step-by-step towards certification success. Today, we'll be covering Section 1.7, Private IPv4 Addressing and IP Classes. In this section, we'll explore how IPv4 addresses are structured and divided into different classes, from Class A through Class E. We'll begin with the definition and purpose of classful addressing. Then, move on to the key characteristics and features of each class. You'll learn about their functions and use cases, and how the bit patterns determine the network and host portions of an IP address. We'll also look at how private and public IP addresses differ, and finish with a quick overview of special IP ranges like loopback and multicast. By the end of this lesson, you'll clearly understand how IPv4 addressing works and how to identify different address types, knowledge that's essential for your CCNA exam and real-world networking. Before CIDR was introduced, IPv4 addresses were organized into 5 classes, A through E. These classes help define how many bits belong to the network portion and how many to the host portion. The idea was to make IP allocation and routing simpler in the early internet days. Class A addresses always start with a 0 in the first bit, meaning the first octet ranges from 0 to 127. The default subnet mask is 255.0.0.0. That's a /8 prefix. It supports 128 networks with up to over 16 million hosts per network. So these are built for very large organizations or ISPs. Class A networks are designed for massive scale, like internet service providers, or large tech companies like Google or Apple. They use it where millions of devices need unique IP addresses within a single network. An example is the public address 12.0.0.1, or the private address 10.0.0.1. Class B addresses start with the binary pattern 10, giving a first octet range from 128 to 191. Its default subnet mask is 255.255.0.0, or /16. This provides a balance: 16,000 networks, each with 65,000 hosts. Perfect for medium-sized organizations. Class B offers a good middle ground. Not too big, not too small. It's commonly used in universities, large corporations, and regional networks. A common private range here is 172.16.0.1 through 172.31.255.254. Class C addresses start with the bits 110, covering 192 to 223 in the first octet. The default mask is 255.255.255.0, or /24. Each network supports up to 254 hosts, ideal for small networks and offices. Class C provides many small networks, making it great for LANs and small enterprises. Most home and small office routers use this range. For example, 192.168.1.1. Public examples include addresses like 203.0.113.10. Class D addresses begin with 1110, so their range is 224 to 239. These are not used for regular unicast traffic. Instead, they're reserved for multicast communication. That means one sender can deliver data to multiple receivers at once, used by routing protocols like OSPF or for streaming applications. Common examples include OSPF, which uses 224.0.0.5, and RIP, which uses 224.0.0.9. They're also used in video conferencing, IPTV, and multicast DNS. Class E addresses start with 4 ones and cover 240 to 255. These are reserved for experimental or research use by organizations like the IETF. You won't see them in production networks. They're strictly for testing or protocol development. Class E addresses are mainly used in lab environments for protocol testing, simulations, or IETF experiments. An example is 240.0.0.1, a non-routable address reserved for research. Here's a quick visual summary. Each class starts with a specific binary prefix, 0 for Class A, 10 for Class B, and so on. This prefix decides how many bits belong to the network versus the host portion. Before CIDR, this was how networks were divided and routed. Each IPv4 class starts with a unique binary prefix that defines its range. Class A begins with a 0, covering 0 to 127. Class B starts with 10, that's 128 to 191. Class C uses 110, or 192 to 223. Class D begins with 1110 for multicast, and Class E with 1111 for experimental use. So those leading bits decide the class and address range. In classful addressing, the first few bits of an IP identify the class, and that pattern decides how many bits belong to the network and how many to the hosts. In Class A, 8 bits are for the network and 24 for hosts, allowing over 16 million hosts per network. Class B splits it evenly, 16 and 16, about 65,000 hosts. And Class C uses 24 network bits and 8 host bits, giving 254 usable addresses. So the more bits you allocate to the network, the fewer hosts each subnet can support. Now let's move to private IPv4 addressing. Private IP addresses are ranges defined by RFC 1918 for use inside local networks. They're not routable on the public internet and must go through NAT, Network Address Translation, to access external networks. The goal is to save public IPv4 space, enhance security, and allow organizations to reuse the same ranges internally. Private IP addresses are used only inside local networks. They aren't routable on the internet and need NAT to reach external sites. Any organization can reuse them without registration, and they add a layer of security by isolating internal devices from the public internet. There are 3 private IP ranges defined by RFC 1918. Class A uses 10.0.0.0 to 10.255.255.255. That's a /8 network. Class B covers 172.16 to 172.31, a /12 block. And Class C ranges from 192.168.0 to 192.168.255, a /16. These are the only private ranges you can safely use inside local networks. Here's how private IP addresses work in real life. At home, your router's LAN might be 192.168.0.1, with your devices ranging up to .254. Hides all of them behind a single public IP. In corporate networks, you might see 10.20.10.0 for marketing and 10.20.20.0 for IT, all private and routed securely through our VPN tunnels. Here's a quick comparison between public and private IP addresses. The difference is simple. Public addresses are globally unique and routable on the internet, while private addresses exist only inside local networks. Private addresses are free to use, reusable across organizations, and rely on NAT for internet access. Beyond the private ranges, a few IPv4 blocks have special purposes. For example, 127.0.0.1 is the loopback address. 169.254.0.0 is a PIPA, used when DHCP fails, and 224.0.0.0 is reserved for multicast. These are not private or public, just special. Let's summarize what we've learned. To identify an IPv4 class, simply look at the first octet. 0 to 127 is Class A. 128 to 191 is Class B. 192 to 223 is Class C. 224 to 239 is Class D, and 240 to 255 is Class E. Private IP addresses are defined by RFC 1918. Class A covers 10.0.0.0 to 10.255.255.255. Class B spans 172.16.0.0 to 172.31.255.255. And Class C ranges from 192.168.0.0 to 192.168.255.255. Remember, some ranges are special, not private, like loopback 127/8, a PIPA 169.254/16, and multicast 224/4. Before moving on, take a quiz to test your understanding. Quizzes, summaries, and slides are available on ccna.academy. If you have any questions, leave a comment below, and I'll be happy to help. In the next section, we'll move from IPv4 to IPv6, the modern version of the Internet Protocol. We'll start with configuring and verifying IPv6, addressing and prefix, where you'll learn how IPv6 addresses are structured. Then we'll cover IPv6 address types.